All right, so this is section 3 of Unit 1. What is peer review? We just finished talking about data, qualitative, quantitative data, collecting, analyzing data, graphing data, looking at it in tables, being able to understand and interpret it, and then also submitting for peer review and receiving feedback on your studies. So when a scientist completes an experiment, those experiments are often submitted for peer review before being published, and peers are just individuals at the same level of education or specialization, which is why your classmates that sit to the left and right of you are considered your peers, because you're at the same level of education or specialization. But in science, your peers are fellow scientists who are well versed in the topic in which you're studying. And these scientists can provide feedback on your research study. Maybe there are flaws that you didn't realize were in the experiment, flaws with the process or the methods or the conclusions. And that allows you to get feedback and improve your research methods, or that scientists can improve upon it themselves. So if the peer reviewers are satisfied, the experimental results can then be published in a scientific journal. And this is a very important way that scientific community safeguards against faulty science. There are cracks, and faulty science has gotten through and been misinterpreted, and sometimes some science has been pushed through that years later scientists will review it and be like, hey, this is wrong based on what we now know. We need to reevaluate this. So again, that's just part of science being dynamic, and it's very important that we continually look at and review things that maybe we thought have been supported in the past, because maybe we have this one idea on this one topic, but the science that underlies that one topic is not very good. It's important for scientists to continually go back and review what has been studied, and do literature reviews and things like that. So in science, I want to talk about this is a very important topic, especially nowadays. What is this? What is a scientific theory? Scientists don't use the term theory lightly, or in the same way that non-scientists do. If a kid in class is coming in late every single day, I might have a theory that I might theorize that they are staying up too late, or they're playing too many video games or whatever. It's just sort of a hunch in the real world is what a theory is, but in the scientific community, it is way more than a hunch. So in science, a theory explains a phenomenon that is supported by many different fields of evidence. And so remember that I said you never want to say that this proves my hypothesis, right? You want to say that this supports my hypothesis, right? And this is much the same way of why scientific evidence is labeled as theory and not law. So scientific theories are broad explanations that apply to many situations, right? So if you think of the theory of evolution, like that's a huge field of science. Amongst others, there's the atomic theory, cell theory, plate tectonics, right? And basically, when you hear theory of evolution or cell theory, atomic theory, germ theory, whatever, that means that it's well rooted in the science. Like it is well accepted as fact. It doesn't mean that elements of it can't be changed, but it's pretty darn solid evidence, right? It's the highest pinnacle of science that you can find, right? So if someone might argue, oh, the theory of evolution, well, that's just a theory, right? It's not a law, and that doesn't work, right? If something is a theory in science, that means it's at the top in terms of being supported by the evidence. So ethics and scientific processes. So scientists must consider the ethics of every experiment, and ethics is the branch of knowledge that deals with moral principles. So there are 3 ethical worldviews that prevail in science. anthropocentrism, which is places the most value on human populations and human welfare. There's biocentrism, which places value on each and every organism, including humans. And then there's ecocentrism, which places value on the ecosystem or community as a whole, rather than just individuals. So over here, asking the question, which worldview does this individual likely have? Ecocentrism, right? So this is important, right? Like there are many studies done, especially in psychology, a few decades ago that you would not be able to get away with doing today, because of laws that have been put in place primarily because of those experiments that are now deemed unethical, whether it's anthropocentrism, or on animals, or whatever the case is, right? And so there's still a lot of studies that are being done on animals that folks disagree with. You know, mice and rats are often used to conduct experiments amongst other animals as well. So, you could talk about the ethics of this and that, and um, you know, different perspectives varied based on what you value the most, right? So, in summary, scientific results can be submitted for peer review and may provide support for a larger scientific theory. All experiments must consider the ethical consequences of their processes and conclusions, right? And that's a wrap for section 3 here.